welcome back to my YouTube channel. In today's video, we're going to talk about different ways to prove triangles congruent. And more specifically, today we're going to talk about the 3 different postulates which allow us to prove different triangles congruent. The first postulate is the SSS postulate. This postulate states that if 3 sides of one triangle are congruent to 3 sides of another triangle, then those triangles are congruent. Let's go ahead and draw a picture to make this a little more clear. Okay, so these are our 2 triangles. We have triangle ABC and triangle FGH. So remember, our postulate tells us that if the sides are congruent to each other, then we can say that the entire triangle is congruent. So let's say that AB here is congruent to FG. Then segment BC is congruent to segment GH, and segment AC is congruent to segment FH. So now that we know that the 3 sides of this triangle are congruent to 3 sides of another triangle, we can say that angle A here is going to be congruent to angle F, angle B is going to be congruent to angle G, and angle C is going to be congruent to angle H. And we can say all of this because we know that corresponding parts of congruent triangles are congruent. So all 6 parts of both triangles will be congruent to each other. And this is known by the SSS postulate. Now let's say that we have these same 2 triangles again, but this time we know that AB is congruent to FG. We know that angle A is congruent to angle F. And we know that segment AC is congruent to segment FH. So now we don't know that all the sides are congruent. However, we know that one side, one angle, and another side are all congruent. This is known as the SAS postulate. The SAS postulate states that if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. So what it means by included angle is basically that the known angle is going to be sandwiched between our 2 known sides. So if I were to draw another triangle down here, and let's say you were told that this side, and this angle over here were congruent to those same sides in another triangle. Well, we could not use the SAS postulate to prove those 2 triangles congruent because the angle over here is not in between these 2 sides. If this known angle was over here, then we could use the SAS postulate. So remember that the angle needs to be the included angle. The last postulate we're going to learn about today is called the ASA postulate. This is when we have an angle, a side, and an angle that are known. So for instance, if we had angle A, side AC, and angle C, and we knew that those were congruent to this triangle, then we could go ahead and use the ASA postulate to prove that these 2 triangles are congruent to each other. The ASA postulate states that if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then these triangles are congruent. All right, let's go ahead now and try some problems. So directions say, decide whether you can deduce by the SSS, SAS, or ASA postulate that another triangle is congruent to triangle ABC. If so, write the congruence and name the postulate. If not, write no congruence can be detected. All right, so if we look at these 2 triangles, we can see that we have one angle, one side, and another angle that are known. Since we have 2 angles and a side in between those angles, or an included side, we can say that these 2 triangles are congruent. We can say this by the A, which is the angle, S, which is the side, and A, which is the other angle, postulate, or the ASA postulate. Now, we need to be careful when naming which triangles are congruent, however. So we know that this side right here, where the 90-degree triangle is A. So we can say that triangle A. And now for our other triangle, which is congruent, we know that the letter by the angle, which is 90 degrees, is N. So we know our first letter is going to be an N. Now let's go and use the segment that we know is congruent. This goes from letter A to letter B. So we know our next letter will be B. Over here, it goes from N to P. So our next letter will be the letter P. Finally, we have one last letter left, so that will be C, and our last letter over here will be Y. So we can say that triangle ABC is congruent to triangle NPY. We need to be really careful when naming triangles because just one discrepancy can change the entire triangle. And we know that these two triangles are congruent because of the ASA postulate. Here is our next problem. We can clearly see that two sides of both of these apparent triangles here are congruent. However, there is no other information that is given. However, in geometry, we know that there are many different properties which we can use. One of these properties is the reflexive property. If you notice, segment AC is the same segment for triangle ABC, as well as the same segment for triangle CKA. So we can say that segment AC is congruent to segment AC in both of these triangles. So now we have three known sides of each triangle that is congruent. The postulate that we can use to prove that these two triangles are congruent is the SSS postulate. The SSS postulate is the postulate that states that if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Now what we need to do is carefully name which triangles are congruent. So let's start off with the side AB. This side has the two little dashes. So now we need to look at our other triangle and see which side has the two little dashes. This would be side CK. Next, we're going to go from B to C, which is the side that only has one dash. The side for the other triangle that only has one dash is side KA. So now that we've labeled our two triangles congruent, we can say that triangle ABC is congruent to triangle CKA by the SSS postulate. Let's try one more of these types of problems. So in these two triangles, we can see that side AB and side HI are congruent, and also that side AC and side HJ are congruent. We can also see that angle C and angle J are also congruent. So by looking at this, one would presume that we could use the SAS postulate to prove these two. However, the SAS postulate clearly states that the angle which is congruent needs to be the included angle. In this case, angle C right here and angle J are not included. In order for them to be included, they would have to be located over here at angle A and over here at angle H because they would be in between the two known sides. So for these two triangles, we can say that no congruence can be deduced. All right, for our last problem, we're going to go ahead and do a proof. So in our given, we are told that AB is parallel to DC. So we can go ahead and draw these arrows which show that these two lines are parallel. We also know that segment AB is congruent to segment DC. What we need to do is prove that triangle ABC is congruent to triangle CDA. Let's first start off by writing our given. Okay, now the next thing we need to do is we need to find some sides which we can tell from the picture which are congruent to each other. So by using the reflexive property, we can see that right here, segment AC is used in both triangles. So we can say that segment AC is congruent to segment AC. Next, we can use something in our given to help us find an angle which is congruent. So remember that if we know two lines are congruent and we view AC as a transversal, we can say that angle C is congruent to angle A because if lines are parallel, then alternate interior angles will be congruent. Let's go ahead and write that. Finally, we need to prove these two triangles congruent. If we look at our picture, we can see that we have one side, an included angle, and another side, which are all congruent. This is exactly what the SAS postulate states. So we can say that triangle ABC is congruent to triangle CDA because of the SAS postulate. Let's take it a step further. For instance, if we were asked to prove that angle D over here is congruent to angle B, how would we say this? Well, it's very simple. Since we know that these two triangles are congruent, we know that every single part of these two triangles will be congruent to each other. So if we were asked to prove this, we would just have to add this one last step at the end. We would say that angle ADC is congruent to angle CBA because corresponding parts of congruent triangles are congruent. You can also shorten this by simply saying CPCTC as well. Thank you guys so much for watching this video about congruent triangles. I hope that you learned a lot and that this video helped you out with your geometry class. Please give this video a big thumbs up if you found it helpful and subscribe to my channel down below if you haven't already. Thanks again so much for watching. I look forward to seeing you in the next video. Bye!